Hello again, Mr. Munyon here with lesson 7-3, perpendicular lines. Hopefully you've already gone through 7.1 and 7.2, learning about angle pairs and relationships on parallel lines cut by a transversal. Now we're going to focus on perpendicular lines. So we still have Matt and his patio that we're working on. Our targets today obviously are to make sure that we know how to make sure that we develop theorems to show that lines are perpendicular, as well as use those theorems to determine if lines are perpendicular. All right, so a second customer of Patios by Madeline is hired by the company to build a patio with rows of bricks that are perpendicular to a walkway as shown. So obviously I see here we have a walkway. We want rows of bricks that are going perpendicular to that. Matt is planning the design for the patio. So far he has extended a line along the walkway labeled with points X and Y. So here's the walkway. He extended a line all the way across. So that he has also drawn a point W to mark another stake. He's going to use that to help create perpendicular lines. So step one is use a protractor to draw the line perpendicular to line line XY that passes through W. Okay, so I need to create a 90-degree angle somewhere on this line here that goes through W. So it's going to be somewhere around here. If you have a protractor, you're welcome to use it. If you don't have a protractor, an easy 90-degree angle is always the corner of a sheet of paper or an index card. So if I take the corner of my index card and slide it up this direction until it goes through W, I should be able to create a nice 90-degree angle. Oops, don't know what happened there. Not the best line I've drawn. You obviously use a straight edge to draw it, but I do know that this will be 90 degrees here that I've measured. That was the corner of my sheet of paper that I used to draw that one, and I can go ahead and label that. Once we do that, it should cross through line XY at some point. It does say call that point Z. So this is going to be point Z right here. Okay, next step says use your protractor and your knowledge of parallel lines to draw a line across the patio parallel to WZ. Explain how we know. So how can we draw another parallel line? Other than just drawing one that looks parallel, what we can do is we can measure another 90-degree angle, either using same side interior angles, or we could use corresponding angles. If I measure another 90-degree angle right here, what I'll end up getting is actually corresponding angles that are congruent. And when you have corresponding angles that are congruent, it proves that the lines have to be parallel to each other. So using corresponding angles, the converse of the corresponding angle theorem, I can create. So I use the converse of the corresponding angle theorem. All right, so I do know those lines have to be parallel to each other. Describe the relationship between the newly drawn line and XY. So aside from these two blue lines that I drew being parallel, what's the relationship? Well, it's also going to be 90 degrees or perpendicular because I measured it that way. So the relationship is it is also perpendicular. And here I use the symbol for perpendicular. So just in case you forgot, this means perpendicular. This little upside down T symbol that we have here. All right, so Matt reasons that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Show that Matt's conjecture is true. Include a diagram. So Matt conjectures that if a transversal is perpendicular to, don't know what happened there, perpendicular to one of two parallel lines, then it has to be perpendicular to the other. That's true. If they're parallel, we know that corresponding angles are congruent. So whatever the angle is here, the other angle, the corresponding angle, has to be congruent on parallel lines, so the other one has to be that same 90-degree angle. We have a diagram. I guess the diagram shows, it doesn't say explain, but we could use corresponding, alternate interior. Doesn't really matter what you use on this one, because either way you get a 90-degree angle down here with congruent angles. I guess you could use same side interior as well. Supplementary angles 90, that makes it perpendicular as well. All right, so Matt draws segment AB, question number 5 now, on his design of the patio so that line XY is the perpendicular bisector of AB. What three conclusions can you draw from this information? So Matt draws AB on his design of the patio so that XY is the perpendicular bisector. Here we have the definition of perpendicular bisector. Luckily, perpendicular is exactly what it sounds like. Bisect, what does that mean? Hopefully we remember that bisect. I think we did angle bisector earlier in lesson 2 or 4, one of those we did them. And we learned that bisect means cut into 2 equal parts. So a perpendicular bisector has both of those properties. It is perpendicular to and bisects a segment. So I'm just going to draw a little diagram here. Let's say that we have line XY. And if I drew a segment AB on this, that is the perpendicular bisector of AB, that means that I would need to draw a segment that is perpendicular to and bisects AB. So I can indicate that both of those properties are listed on there. That's why. So it is segment AB here has equal half on the left side and right side, or bottom and top, of line XY. That's bisected, and obviously the perpendicular symbol there shows that it is perpendicular. List 3 conclusions that we could draw from this information. If we did this on the diagram up here, we could do a few things in relation to the other blue lines we've already drawn, but instead let's just focus on this diagram. Let's call this, what does it say up here? Point M. They intersect at point M. So what do I know about this? I know that M is the midpoint. I know that AM equals BM. And I know that AM plus MB equals AB. So those are 3 easy things that I could do based on this information. I know that M is the midpoint. I know that AM equals BM, and I know that AM, oops, I guess I'll write it so it makes more sense. So because it's bisected, I know that it's cut into 2 equal parts. Those 2 halves are equal. And then segment addition says the 1 half plus the other half has to add up and equal the whole thing. AM plus MB does equal the whole thing AB. Obviously, if it's bisected, M is going to be the midpoint. Right, number 6. Matt's boss, Madeline, is so impressed with Matt's work that she asked him to write an instruction guide for creating rows of bricks parallel to a patio walkway. Madeline asked the guide provide enough information that a bricklayer can use any pair of angles, same side interior or alternate interior, corresponding to determine the location of each pair of stakes. She also requests that Matt include directions for creating rows of bricks that are perpendicular. Write Matt's instruction guide following Madeline's directions. So take a moment, see if you can come up with something. I'll put an example answer up here in just a second. So pause the video, see what you come up with. I'll post the answer in just a moment. Alright, so here we have the answer for 6. In order to make rows of bricks that are parallel to a patio walkway, you need to draw a transversal and then create an angle pair of either corresponding angles that are congruent, alternate interior angles that are congruent, or same side interior angles that are supplementary. To create rows of bricks that are perpendicular to a walkway, just line up stakes or lines so that they intersect the walkway at 90 degrees. That way they make sure they're perpendicular. Any additional lines you make also need to intersect at 90 degrees. So let's try the check your understanding in lesson practice. Pause here a moment and try questions 7 and 8. When you unpause, you can check your answers. Alright, so here it says lines A, B, and C lie in the same plane. If A is perpendicular to B and B is perpendicular to C, can you conclude that A is perpendicular to C? Explain, include a drawing. So let's go ahead and make a drawing. So here we have lines A, B, and C. A is perpendicular to B. So let's make A and B perpendicular. And B is perpendicular to C. Can we conclude that A is perpendicular to C? Definitely not. Based on the drawing, it looks like they're parallel, not perpendicular. So, nope. They would be either coinciding and be the exact same line on top of each other, or they would be parallel to each other. Number 8, segment RS is the perpendicular bisector of segment JL. So RS is the bisector, perpendicular bisector of JL. It's already listed as perpendicular, but if it's the bisector of JL, that means it's cutting JL in half. So here I would need to indicate RS is doing the bisecting of JL. JL is the one that's getting bisected. All right. Can you conclude that point K is the midpoint of RS? Well, it looks like it kind of is, but do I know that RK right here equals KS? No. K is the midpoint of JL, because JK is equal to KL. JL was the one that got bisected, so K is in the middle of JL, not RS. Not RS. All right, same thing. You guys have a moment here that you guys can see if you want to try questions 9 through 13. Pause your video now. In just a moment, I'll go over it. All right, so hopefully you had some time to go over questions 9 through 13. Let's check our answers. In the diagram, L is parallel to M, so let's go ahead and mark that. L is parallel to M. Measure angle 1 equals 90. 5 is a right angle, so also 90 if you want to put that on there. Use the diagram here. Explain how we know that L is perpendicular to P. That's the definition of perpendicular, or right angle. Perpendicular means intersect at 90 degrees. A right angle is 90 degrees. Show that the measure of angle 4 equals 90. Well, if these are parallel lines cut by a transversal, corresponding angles are congruent, so this is 90. Then we could use a linear pair here to prove that one. So corresponding angles 1 and 3, and then linear pair 3 and 4. These have to be supplementary, so 90 plus 90 equals 180 for that one. For question number 11, it says show that L and N are parallel. We could use the converse of the corresponding angle theorem, because if 1 and 5 are corresponding and congruent, that proves that the lines have to be parallel. So the converse of corresponding angle theorem. For number 12, the perpendicular, it looks like we can use a different diagram here, so let's have some room. The perpendicular bisector of CD intersects CD at point P. So here I have a segment CD. The perpendicular bisector intersects at point P. If CP is 12, what is CD? All right, well, I don't know if this is a line or array or what. You can draw something there, it doesn't matter. But if CP is 12, oh, it says perpendicular, so I guess I should draw it perpendicular if nothing else. All right, if CP is 12, so this little piece here is 12, what is CD? Well, the other half has to be 12. So then that means the whole thing would be 24 using segment addition postulate. So the whole thing would be 24. All right. Number 13, an angle formed by the intersections of two lines is obtuse. All right, so here's an obtuse angle. Could the lines be perpendicular? Explain. Definitely not, because if they were perpendicular, all of the intersections would be 90 degrees. You can't have an obtuse and an acute angle here and then have the lines be perpendicular. To be perpendicular, all of them have to be 90 degrees. So definitely no. All right, so now that we have finished with 7-3, you should now be ready to do the activity practice. This is where your homework is at. So check out the homework. I don't know exactly what questions you have, but make sure you complete the listed questions from the homework assignment schedule that you have. And these are the questions that you'll be going over at 7:30 in your classes if you have any. You can check your work as well as go over any questions there. All right, take care until next time.